So I'm Dr. R. Venkatesh Kumar, working as Assistant Professor in the Department of Mechanical Engineering, BV Raju Institute of Technology, Narsapur. So my course name is about Essential of Mechatronics and Robotics. So my topic name here it is Introduction to Industry 4.0 and its applications. So we will see the definition of mechatronics first. The word mechatronics is derived from this combination of two words, mecha plus tronics. It means that it is derived. It was invented by a Japanese engineer, Tetsuro Mori, from Yasuko Electric Corporation in the year of 1969. As I said earlier, it is a combination of mecha plus tronics. So mecha gives the meaning about mechanisms, and tronics are derived from the word electronics. So mechanism is usually a piece of larger process, so known as, we'll commonly name it as mechanical system, or some cases we'll name it as simply machines. Machines will involve group of mechanisms, will name it as machine. So for example, it's a steering mechanisms in a car, or winding mechanisms in wristwatch. So these are however, typically a set of multiple mechanism will be called as a machine. So this is the definition about mecha, nothing but mechanisms. Next word is tronics. So tronics is derived from the word electronics. So you know that it is a branch of engineering, will be having electronics and communication engineering. So these words derived from this electronics. So electronics is nothing but a branch of physics which deals with the theory and use of devices which the electrons travel through a vacuum, gas or semiconductor medium. So here the flow of electrons will be taking place inside the vacuum, gas or some semiconductor medium. So the motion of electrons takes place under the influence of how we are going to influence this making the movement of electrons with the help of applied electric or magnetic field. So here some cases we will use some directly we will use for electric field, and some cases we will go for this magnetic fields, and some cases it will be combination of both electric and magnetic fields applied together, and this movement of electrons will take place inside the electronic components. So this mechatronics is an integration of across all branches, core branches of engineering, specifically mechanical engineering, electrical engineering, electronics and control engineering. This group of engineering branches supporting to make the concepts of mechatronics. So it is an interdisciplinary course where the students get benefit in getting core jobs in all those industries and all core branches of engineering. So this is what here the definition about mechatronics brings together areas of technology that involves components from sensors and measurement systems, drive and actuation system, and these parts, sensors and measurement systems, drives and actuation system, these parts will be comes under the part of mechanical components, since all those components are manufactured with the help of mechanical engineers, as well as these microprocessor systems, and together with the analysis of the behavior of the systems and control system. Here this knowledge about electronics and communication engineering people is required here. So it is a combination of all core branches of engineering, specifically for mechanical engineering as well as electronics engineering. So now we'll see the history or evolution of mechatronics. So we'll start from the history from half of the 19th century, that's from 1950s to 1960s. So during that 10 years of time, that is, emergence of control engineering plays the major role. So here, control engineering comes into the play in the year of 1950s to 1960s. It is nothing but we are started earlier days. We have used mechanical system separately, electrical system or electronic system separately we used to have. After this, during the transition period of 10 years, 1950 to 60s, we started using the control engineering concepts, where control theories we are applied in the part of mechanical systems and leading to the development of feedback control systems. So there will be a feedback control system which will be helpful in the evolution of mechatronics. So from 1950 to 1960s, we started using the control engineering concepts. From 1960s, we started introducing this microelectronics. Microelectronics in terms of it is nothing but 10 to the power of minus 6 meters. So this widespread of adoption of microelectronics is like miniature of components. Electronic components are made in the form of small components. It plays a major role in the evolution of mechatronics. So here the ability to integrate electronic components and miniature circuits. So after 1960s, we started using this integrated electronic components and miniature circuits allowed for the development of more. Why we are going for microelectronics? It gives a more compact and sophisticated control systems. And then after 1960 to 1970s, during the period of 10 years, rise of robotics came into the play. So here it is the industrial, robots are we are using for robots. Normally we are using robots for repetitive tasks. When we are preferring the repetitive task, we used to have the humanoid robots. Nothing but this. It comes into the play of 1960 to 1970s, which plays a significant step towards the mechatronics. So these early robots were designed to perform the repetitive task on manufacturing assembly lines, combining mechanical components with electronic control system. Since already it started with control engineering concepts and miniature of electronic components where comes into the play. After that, we are combining these two concepts as well as and robotics, and that will be comes inside in the year of 1970s. Later on during the period of 1970s and late 1960s, that gained popularity. The word mechatronics word is framed in Japan with the help of Japan Industrial Robot Association adopted the term exactly in the 1971, but this word is framed in the year of 1969. So to describe this integral and electronic components in the design of intelligent systems. So in 1970s, mechatronics word is framed, right? Next, after So after 1970s, 1980s, we started integrating the computer science, since it plays some major role in this part of mechatronics. So 1980s saw the integration of computer science into mechatronics, leading to the development of, earlier we have a control system, electronic miniature of microelectronics schemes, and after that we integrated both and robotics scheme. Next, after mechatronics word is coined in the year of 1969. After that, 1980s, we started integrating computer science for this computer controlled system along with the microprocessor and advanced softwares. So here it is integral into the design and control the mechatronic systems. So after 1990s, this proliferation of mechatronics applications comes into the play. So here we have started using these mechatronics components, and we got this application over in the year of 1990s. So mechatronics found application where in the field of automotive system we started already using in the 1990s, aerospace, consumer electronics and medical devices, and these are some applications we started using mechatronics. So after 2000s, so advances in the sensing and connectivity part. So in this during the period of 2000s, we started using the advancement in the sensing as well as the connectivity part. So the integration of sensing in the sense sensors, we are integrating sensors, actuators and communications together, allowed for the development of smart and interconnected mechatronic systems. So in this period of 2000s, we started using all those mechatronics elements together, and we are introducing the new concept as development of smart and interconnected of mechatronic systems. So next, after 10 years of time, 2010, we started using this autonomous systems. So these autonomous systems in the field, in the sense robotics and here already we framed this robotics, we are used in the industry part, robotics and automation. So increased emphasis and the integration of AI, artificial intelligence and machine learning became more prevalent. So after 2010 itself, we started using AI and machine learning in the field of mechatronics. Next, current trends we are in that industry 4.0 and IoT integration in the previous years itself. So mechatronics is evolving in the context of industry 4.0. Here what the new concept is coming here, it is integration of digital electronics as well as internet of things, and we are using this cyber physical systems. So these are the concepts we are introduced in the current in the industry 4.0 and IoT integration. So now we are updated to this industry 5.0. So these are the evolutions of industrial revolutions. So first we'll start with the industry 1.0. It's with the mechanization, water and steam powers. With the help of these powers during the 18th century, industry 1.0 started, and after that industry 2.0, it's nothing but during the period of 19th century. After that, so mass production, we have started using electric power, assembly line, we have started using. Next, after the 2000s, we started using this industry 3.0. So here we started computers, automated, as we saw previously, like history or evolution of mechatronics. So from the year of 2000, we started integrating automated production, electronics, computers will be also integrated. So same in the industry 3.0 will be started from 2000. So after 10 years of time, we immediately updated to this industry 4.0, so which integrates the cyber physical systems, IoT, networking, machine learning. So these things will comes in till 2010. After 2010, within the period of 10 years, we came to this industry 5.0. It's nothing but human robot collaboration, cognitive systems, customization. So this thing currently we are in this stage of industry 5.0. These are the revolutions under the industrial part. So now we'll move to the next one, applications of mechatronics, and we'll see these different applications under various areas. So first we will start with this automatic system. Especially we are using anti-lock braking system, electronic stability control, adaptive cruise control, automated transmission system, even electric power steering also we are using this mechatronics components. And in the field of manufacturing and robotics part, we are especially in assembly and welding line, we are using industrial robots and automated guided vehicles over the industries, and CNC machines, computer numerical control for pick and place objects for the systems, we are using mechatronics. And in material handling system also fully automated nowadays in industries part. So next, under the area of consumer electronics, we will be having smart home devices such as we are day to day life we are using thermostats and security systems. That will be comes into the smart home devices, digital cameras with autofocus, image stabilization, 3D printers. Nowadays we are using 3D printers for manufacturing sector, and home automation system. And these are the consumer electronics part. We will be having different applications. Next we will move to the aerospace and aviation field. These are the few applications like flight control system, unmanned aerial vehicles and drones for in the aerospace and aviation field, aircraft navigation and avionics, and space exploration rovers. And when it comes to the medical system, surgical robots assisted surgery, prosthetics and exoskeletons, we are using mechatronics applications, and automated drug delivery systems, patient monitoring systems. Say for example, like doctor will be in USA and he can able to monitor patient from India, simply integrating all those mechatronics like connectivity, IoT. Will be integrating with all those mechatronics components like sensors, actuators, networking part, and cyber physical security. Everything we are integrating, and with the help of this, a patient can monitor from anywhere else in the world, right? So diagnostic imaging equipment, now technology is everything modified. Within a fraction of a second, we can find results of any testing facilities we can do with the diagnostic imaging equipments. So next we will move to this military and defense applications, unmanned ground vehicles, autonomous surveillance systems, smart weapons, guided missiles, surveillance and reconnaissance drones. For drones applications we are using this. So home appliances regularly we are using smart refrigerators with temperature control, washing machine with automated cycles, robot vacuum cleaners, smart ovens and cooking appliances. These are some applications we will be using mechatronics in the areas. And comes to this environmental monitoring, we will be using automated weather stations. Even though like we are using smartphones, so we can monitor the temperature of current today's scenario and tomorrow's scenario, how the temperature will be varied. Everything now to moving predictions of we are integrating some AI tools, and we can able to predict weather predictions. Everything is possible nowadays. Air quality monitoring system, water treatment plants with automated control, remote sensing devices. For environmental research we are using this thing like how much pollution we are getting over in a particular area, what is the content of greenhouse gases, what are the gases, how much quantity it is available. Like that we can monitor with the help of this mechatronic systems. And when it comes to the next part, important backbone of India like smart agriculture, precision farming equipment, automated tractors and harvesters we are using, and drones for crop monitoring. We can monitor the crops by using the drones. Like in olden days we can manually feeding fertilizers for the crops. Nowadays we can, with the help of drones, we can use the drones for spreading the fertilizers. And soil environmental sensors and traffic. Next come to the applications like traffic and transportation systems. In that we'll be having intelligent transportation systems, automated toll collection systems, traffic light control systems, autonomous vehicle and self-driving cars. These are some applications under the traffic and transportation systems. So even though like we are using mechatronics in the field of entertainment and gaming part, simulators for training purposes like flight simulators, driving simulators, virtual reality and augmented reality systems, we are using mechatronics, and motion controlled gaming consoles. When it comes to this industrial automation part, we will be having PLCs, programmable logic controllers, automated manufacturing cells, in SCADA systems, nothing but data acquisition system, supervisory control and data acquisition systems. And next to that we will be having remote monitoring and control systems. These are some applications of mechatronics. And nowadays without mechatronics nothing is inside the world. Like everything is integrated with the concepts of mechatronics. That's why these are the major applications of mechatronics. Comes to this objectives of mechatronics. What is the objective of mechatronics? We'll start with the first one. As I said earlier, how this evolution of mechatronics came. So first is nothing but integration of all those core branches of engineering. System integration. The first objective is like system integration. Integrate mechanical components, electronics, computer systems and control engineering to create a unified and efficient mechatronic system, right? So we are integrating all those core branches of engineering which are like mechanical plays a major role in it, and after that electronics, and we are integrating computer systems, AML and control engineering also. This plays a major role. Here the main objective is like system integration is happening here. And next one is like product development. Here we are able to, with the help of mechatronics we can able to design and develop intelligent products and systems that combines of mechanical functionality with electronics as well as smart control. With the application itself, we get to know that everything is like smart, automated for that applications. Next objective is like automation. Here in this automation, implement automation in various processes to improve. Why we are going for automation? Like we have to improve the efficiency, accuracy and reliability in majorly in manufacturing industry and other applications. Next objectives like developing control system. Here we are going for a develop advanced control system to regulate, and here we are doing the optimize the performance of mechatronic system and ensuring the precision and responsiveness. So we are next objectives like with the help of sensors and actuators, how we are going to create the effective mechatronic system. So utilize sensors to gather information. Since sensor is an important component in mechatronics, it will gather the information from the environment, and from the sensors part, the sensors output will be like electrical signal, and after the sensors part electrical signal, again will be depending upon the electrical components like amplifiers, filters. After that we have to move to the signal conditioning part. We'll be having microcontroller able to read only binary digits. Again we'll be having ADC, analog to digital converters, and after that, since again that information has to pass to this actuators part, again it has to be converted into digital to analog signals. So we will be having microcontrollers with the help of this microcontrollers, and after that microcontrollers like brain of the system. So here we have to utilize this optimized use of the sensors and actuators part to change in the physical system, enabling a closed loop control system. Like it depends upon the feedback, right? So closed loop control system mechanisms nothing but it will be getting it depends upon the feedback. Input is it depends upon the feedback of the output. Next, human machine interaction. Improve the interaction between humans and machines by incorporating user-friendly interfaces and control mechanisms. So whatever mechanism system we are creating here in this world, that should be like user-friendly and easily understand, and it make the user to interact easily. Right, user friendly interfaces and control mechanisms. And next one is like robotic system. This is main objective of mechatronics. Like we are designing and implementing a robotic system for applications such as manufacturing, healthcare and exploration, combining mechanical designs with intelligent controls. And finally, ultimately, whatever systems we are using, energy is ultimate. So we have to optimize the energy usage. So focus on designing mechatronic systems that energy, whatever we are consuming for mechatronic system, that should be efficiently used, and it should be like environmental sustainable one. And here the next objectives are like interdisciplinary collaboration is there, right? So here encourage collaboration among various core branches of engineers like mechanical, electrical, computer scientists and control engineers to leverage the strength of each discipline for comprehensive problem solving, since all those core branches help us in creating the effective mechatronic system. Next objective is like innovation and research part. Drive innovation through continuous research and development in mechatronics, exploring. Mechatronics like it should be like updated one. Every R&D works are nowadays we are doing in this part of new technologies, exploring new technologies and methodologies to enhance system performance. Next objectives of mechatronics like it should be like cost effectiveness. We have to aim to develop mechatronic solutions that are cost effective without compromising the main important parameters, quality and performance. Without sacrificing this thing, without compromising quality and performance, we should develop the mechatronic solutions. Next one is adaptability and flexibility. We need to design mechatronic systems that are adaptable to changing conditions and can be easily modified or upgraded to meet the evolving requirements. And finally, safety and reliability are most important. So prioritize the safety and reliability of mechatronic system, ensuring that they meet industry standards and regulations. So these are some objectives of mechatronics. Next we will move to the advantages and disadvantages of mechatronics. We will see the advantages of mechatronics. So first advantages, like since it is as I said earlier, like objectives like integration of system integration should be there, integration of all those core branches of engineering. So high level of integration is there, and increased functionality and design. And here also we are using electronics components which is in the microelectronic components are there. So more use of electronics and software instead of mechanical functions. Assume responsible for process and operations with little interference of operators, and we are using AI and intelligent process control here, multi-sensor and program environment we are using. These are some advantages. High reliability and safety should be there. Improved and less expensive controls, provides increased. So ultimately, when you are going for automation, there will be like provides increased productivity on the shop floor, and results in automation will be increase the production, assembly and quality control. These are few advantages of mechatronics. And come to this disadvantages of mechatronics, like initial cost is high when compared to the conventional systems. So complicated design and system, The repair and maintenance is complex. So with the core knowledges only we can rectify the mistakes happen in a mechatronic system. So the repair and maintenance is complex here, but it is essential to have a core branches knowledges. And next disadvantage, its replacement is difficult. It is difficult to change old system to new system. So already I started like every components are moving towards a miniature of electronics components, and we are using maximum sensors and actuators part. So here if you are using sensors, then automatically the power requirements would be more. The increased power requirements, real-time calculations or mathematical models. These are some disadvantages. The concurrent integration of mechatronic system design requires multidisciplinary knowledge. So here all those core branches of engineering requires knowledge is required here. Call for training and reorientation of the workforce in design and manufacturing field. These are some disadvantages of mechatronics. So next topic is philosophy of mechatronics. As I told you earlier, like we have covered all those things. So mechatronics is nothing but mecha plus tronics. We will be having mechanical components as well as electronic components, and all computer science. Mechatronics is the interconnectivity. It will connect computers as well as mechanical components like actuators, sensors, robots, softwares like CAD, mechanical CAD we can use, and simulation softwares also we can use. And this will be having electronic control systems, and with the help of electronics. So it's this entire philosophy of mechatronics will tell about it is the system integration of all core branches of engineering, right? So the combination of technology and intelligent control can combine theory and technology to form a variety of efficient control method to achieve effective management of system and equipment, enabling mechatronic system to play a more active role in computer CNC part, like machinery manufacturing part, robotics part, and other fields. Thus ensuring the ultimate use of mechatronic system is to ensure the accuracy and efficiency of production and management, reducing the human as well as material cost, and providing strong support for industrial production. Ultimately we should that mass production should be there without compromising the quality and cost. So these are the philosophy of mechatronics. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.